Good morning, all of you. Welcome to Sri Chandra Zone. Today we are discussing new topic in thermodynamics. That is, the previous lecture we have done about spontaneity and entropy. Now we are going to discuss new topic, that is Gibbs energy, Gibbs free energy. So this is the last concept in this chapter, but we need to do more number of numericals. So today we are going to discuss new chapter. Sorry, not new chapter, new topic in this lecture. So let us see now. So what is Gibbs free energy? What is Gibbs free energy? Now we are going to discuss. So it is nothing but the free energy of the system. A new state function called free energy incorporates both enthalpy and entropy into a single property. Very, very important. So a new state function called free energy incorporates both enthalpy and entropy into a single property of the system, which is commonly called as free energy. Free energy is an extensive property. It is depending upon the quantity of matter, while molar free energy is intensive property. So whenever we have molar energy, molar volume, molar specific heat capacity, molar heat capacity, all these are called intensive properties because they do not depend upon quantity of matter. And free energy is an extensive property because it is depending upon quantity of matter. Its units are joules per mole or kilojoules per mole. And mathematically, free energy is equal to heat enthalpy minus T into S, where T is called temperature and S is called entropy. So this is called G. G is equal to, that is Gibbs free energy is equal to H minus T delta S. And for a process at constant temperature and pressure, this is very important. So if the process is taking place at constant temperature and pressure, delta G is equal to delta H minus T delta S. So delta G is equal to delta H minus T delta S. So this is called Gibbs free energy. So change in Gibbs free energy is equal to change in enthalpy minus temperature into change in entropy. This is delta S is called change in entropy. Change in entropy. I hope it is clear. So let us discuss now what is this Gibbs energy. The free energy associated with the system is called Gibbs free energy, and this free energy incorporates both enthalpy and entropy into a single property of the system. I hope it is clear. So let us take one more slide. So this is Helmholtz equation, Gibbs-Helmholtz equation. Very, very important. Delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T delta S. So this is the Gibbs free energy is the free energy is a state function which incorporates both enthalpy and entropy into a single property of the system. I hope it is clear. Now what is Gibbs energy? Continuation. Gibbs free energy is a measure of available energy in a system. So the available energy in a system is called Gibbs free energy. Decrease in free energy, delta G, is the measure of maximum work or useful work. So if a system does work, what happens? It's Gibbs free energy is nothing but obtainable from a reversible process at constant temperature and pressure. So decrease in free energy, that is enthalpy free energy change, that is delta G, is also called as free energy change, is a measure of the maximum work or useful work obtainable from a reversible process at constant temperature and pressure. So this is called Gibbs free energy. Now, what is standard Gibbs free energy change? That is nothing but at standard conditions. When 1 mole of a subcompound in its standard state is formed from its constant elements also in their standard states. So standard free energy of formation is defined as the free energy change that occurs when 1 mole of a compound in its standard state is formed from its constant elements also in their standard state. So this is called standard free energy change of the reaction. By convention, the standard free energy of formation of an element in its standard state is assumed to be zero. Like delta S in element state is assumed to be zero. Same way, the standard free energy of formation of an element in its standard state is assumed to be zero. So delta GF of oxygen is equal to zero. Delta GF of bromine liquid is also zero. Delta GF of graphite is also zero. It is in solid form, liquid form, and gaseous form. I hope it's clear. So let us see now what does this standard free energy gives us. It is a free energy change that occurs when the number of moles of reactants indicated by the balanced chemical equation have completely reacted to give the products, the reactants and products being in their standard states. So standard free energy change of a reaction is given by delta G of the reaction is equal to delta H, enthalpy of the reactants minus T delta S of the reactants. Also, delta G of the reactant is equal to delta GF of products minus delta GF of reactant. Sigma delta GF means all the products. Enthalpy change of products minus, free energy change of products minus free energy change of reactants. So just like how we'll find heat of reaction, in the same way we'll find standard free energy change of the reaction. It is equal to sigma standard free energy of formation of products minus sigma standard free energy of formation of reactants. So this is called standard free energy. Let us see next question now. Let us now develop the criterion of spontaneity in terms of Gibbs energy change. We have learned earlier that the total entropy change during a process is given by delta S of system is equal to delta S of total is equal to delta S of system plus delta S of surroundings to be delivered till minus T delta S is equal to delta G of the system. So this is called delta G of the system. Now, what is delta G and spontaneity? For a process to be spontaneous, delta S should be positive. As we already know, delta S should be positive total. And so the delta G of system also becomes negative. Thus, for a process at a given temperature and pressure to be spontaneous, the Gibbs energy of the system must decrease. That is, delta G at constant temperature and pressure should be less than zero. So what is the spontaneity condition? Delta G degree must be less than zero. Delta S should be greater than zero. And delta H can be either negative or positive. So usually for most of the reactions it is negative, and for certain reactions it is positive. So delta H can be positive or negative. But these two are same. So for a reaction to be spontaneous, delta G should be less than zero. So if delta G value is negative, the reaction is spontaneous. If delta G value is positive, so the reaction is spontaneous, or the process is spontaneous. So similarly, if delta G value is equal to positive, non-spontaneous. Like that, if delta G is equal to zero, the reaction is at equilibrium. The reaction is at equilibrium. So these conditions, anyway, I have prepared it one more slide. So since we want to discuss all, so that's why I have discussed here. So for a process to be spontaneous, delta S total, that is entropy, change in entropy total should be positive. So the delta G of system should be negative because delta G is equal to delta H minus T delta S. So if this is positive, this should be negative. Thus, for a process at a given temperature and pressure, to be spontaneous, the Gibbs energy of the system must decrease. That is, delta G at constant temperature and pressure should be less than zero. I hope it is clear. Let us see now. These points you write in your classwork. So the criteria of spontaneity in terms of free energy change of the system and also in terms of the entropy change of the universe, that is as follows. Very, very important, this table. From this table, definitely they'll ask one question. So please note down this table, very, very important. So nature of process, spontaneous. Free energy criterion, delta G should be less than zero. And energy entropy criterion, delta S should be greater than zero. Non-spontaneous, delta G greater than zero, delta S less than zero. At equilibrium, both will be equal to zero, as I told you in the previous slide only. So at equilibrium, if delta for all reactions which is at equilibrium, delta G at constant temperature and pressure should be equal to, at constant temperature and pressure should be equal to 0, and delta S of universe also should be equal to 0. So I hope it is clear. So this table is very, very important. From this table they'll ask the questions, theoretical based questions. Next, delta G and spontaneity. Using delta G as a criterion for spontaneity has the advantage that it deals only with the system. On the other hand, in order to use delta S as a criterion for spontaneity, we need to know the entropy change of the system as well as that of surroundings. But for delta G, only system is concerned. That is the main difference. That's why it's easy to concern delta G, because it concerns only, deals with only with the system, whereas delta S deals with not only entropy change of the system as well as that of the surroundings also. So that's why delta G should be better criterion for spontaneity than delta S. That's why for a spontaneous process, delta G should be negative. For spontaneous process, definitely for all feasibility, spontaneity or feasibility, delta G should be negative, and delta G is equal to positive if it is non-spontaneous or non-feasible. Non-spontaneous or non-feasible, you can see the words. So here we'll say non-spontaneous or non-feasible, and delta G is equal to 0. The reaction is at equilibrium. The reaction is at equilibrium. Or the process is at equilibrium. Not only reaction, process also you can say. So it is reaction or process is at equilibrium. So this is called equilibrium. I hope it is clear. So please note down all these points, very, very important. So using delta G as a criterion for spontaneity has the advantage that it deals only with the system. Whereas if we take delta S as criterion for the spontaneity, we need to know the entropy change as well as that of the surroundings, entropy change of the system as well as that of entropy change of the surroundings. So that's why it's easy to find for delta G. I hope it's clear. Next, effect of temperature on spontaneity of reaction. This table is most important. So depending on the temperature, which is positive, which is negative, we are going to discuss. So delta H of the reaction, that is enthalpy change of the reaction, entropy change of the reaction, and free energy change of the reaction. So enthalpy change, entropy change, and free energy change. Now, if the reaction is spontaneous at all temperatures, then delta H should be negative, that is enthalpy change should be negative, and delta Rs, that is entropy change of the reaction, should be positive, and delta G of the reaction, that is free enthalpy change of the reaction, should be negative. First condition, this is the first condition. From this, any conditions they can ask from this table. So the, if delta H is negative and delta S is positive and delta G is negative, we can say that reaction or that process, either physical process or chemical process, so that process is spontaneous at all temperatures. Reaction or process, both are spontaneous at all temperature. Next criteria, second condition, if delta H is negative and delta S is negative, it should be positive. Delta G also will be negative only at low temperature. So for example, if we take, why? Because delta H is equal to, delta G is equal to delta H minus T delta S. So if temperature is low, then this total becomes low. So minus and minus. So minus and minus, total you'll get it as minus finally. So as delta S is negative, negative of negative is positive, and delta H is at low temperature, this is positive. Negative of negative becomes positive. So this becomes, delta H is already given negative. So in this case, delta H should be greater than T delta S. Why? Because you'll get minus sign. So by using this equation, so delta G is negative only at low temperature. So the reaction is spontaneous only at low temperatures. So this is the second condition. Third condition, if delta H is negative, that is enthalpy change for a reaction is negative, entropy change for a reaction is also negative, and delta G should be positive. This is possible only at high temperatures. The reaction is non-spontaneous at high temperatures, because If delta G is positive, the reaction is non-spontaneous at high temperatures. I hope it is clear. The same condition, the reaction is at low temperature, reaction is spontaneous, and at high temperature, reaction is non-spontaneous. Means that process is not possible at high temperatures. I hope it is clear. Next. So this table is very, very important. More conditions we'll discuss now. Next condition, if delta HR, that is enthalpy change for the reaction, is positive and entropy change for the reaction is also positive, then delta G will become positive at low temperature. Reaction non-spontaneous at low temperatures. And for the same conditions, if delta H of the reaction is, that is enthalpy change of the reaction is positive, entropy change of the reaction is positive, and delta G becomes negative when if it is at high temperature. If it is high temperature, automatically you can see here, if T is high, then delta G for this reaction is equal to delta H minus T delta S. Delta H minus T delta S. So since delta H is positive, they are given minus T into positive. So this becomes negative totally if T is higher, if T is more high, it is at high temperatures. And if all are positive, so then at low temperature, this becomes positive and the reaction is non-spontaneous. So under what conditions the reaction is spontaneous, they'll ask the question. But definitely they'll ask question this table from this table because for so many entrance exams, this table has come based on this table. Table means based on this table, how the questions will be formed, I'll discuss now. Next, after this table, next, if delta H is positive and delta S is negative, this is positive. Reaction is non-spontaneous at all temperatures. So delta S entropy is negative means it is non-spontaneous, and delta G is positive means non-spontaneous. So please see these changes, very, very important. And these values, this table is very important for numericals and theoretical questions based on this concept. Next, relation between standard free energy and equilibrium constant. Equilibrium constant, next chapter we are going to discuss, that is chemical equilibrium. So the standard free energy change of a reversible reaction and its equilibrium constant are related as delta G is equal to delta G degree plus RT ln K, that is natural logarithm. At equilibrium, delta G is equal to 0. So delta G is equal to minus RT ln K, which is also equal to delta G is equal to minus 2.303 RT, where R is called gas constant. For removing natural logarithm, you have to use this formula. That is 2.303 will come in place of natural logarithm. R is gas constant, T is temperature, and this is log K. ln K means natural logarithm log K, where K is called equilibrium constant. Here K is called what? Equilibrium constant. So this is the relation between standard free energy change of a reversible reaction and its equilibrium constant. I hope it's clear. So this formula we are going to use in the numericals. Next questions now. Calculate the standard Gibbs energy change for the following reactions at 298 kelvins using the value of delta G of formation. Let us see now. CH4 plus 2O2 gives rise to CO2 plus 2H2O. CH4 plus 2O2 gives rise to CO2 plus 2H2O. And this is gas, this is gas, this is also gas, this is also gas. And calcium carbonate plus 2H plus gives rise to Ca plus 2 plus H2O plus CO2. So given that values of delta Fg at 298 kelvins in kilojoules per mole is as they are given delta G, that is free energy change of the formation of methane, carbon dioxide, water in gaseous form, and calcium carbonate, H plus ions, and Ca plus 2 ions. So all these values are given. So first equation we'll find, also we'll find second equation. So let us see now first equation. I'll do it at first equation, and then remaining you do it second equation. So delta G, standard free energy change of the reaction, is equal to sigma of delta G of formation of products minus sigma of delta G decay of formation of reactants. So we simply use this formula for first and second. So first I'm doing it here. So that is products. In the first case, what is the product? Carbon dioxide, water. So 2 moles, 2 moles. Gas is there, gas is there. So we have to consider. So that is 2 into, what is the formation of carbon dioxide? Minus 394.4 plus, only products I'm doing now. 2 into formation of water. 2 into formation of water is gases form minus 228.6. Minus 228.6 minus sigma delta G of reactants. First methane, then oxygen. For methane, only 1 mole. So 1 mole, that is 1 into 50.8 minus in plus 2 into, what is the formation for oxygen? For oxygen, it is 0 because it is not given. So for oxygen, no need to take into consideration because CH4, CO2, H2O, H2O, CaCO3, H plus Ca plus 2. So individual, it is 0. So it is 0. So if you calculate this, you will definitely get the answer. So 2 into minus 394.4 plus 2 into minus 228.6 minus 50.8 for the formation of the reaction. So let us see the answer now. So it is minus 800.8 kilojoules. First case, it is what? Minus 800.8 kilojoules. You can substitute the values and you can do it. I hope it is clear. So 2 into minus 394.4 plus 2 into minus 228.6. So just you have to add, keeping minus and minus of minus becomes plus. For that, if you remove 50.8, you'll get the answer. I hope it is clear. Next. Second question also the same way. Reactants, whatever it is given, you have to take products, same thing. So you will get minus 800.8 kilojoules and minus 56.4 kilojoules. Next question. Calculate the free energy change for the following reaction at 300 kelvins and predict whether the reaction is spontaneous or not. This is very, very important question. This model. So if delta G becomes negative, we can say it is spontaneous. Otherwise, non-spontaneous. They are given delta H and delta S also. And they are given temperature also 300 kelvins. So we know the formula. Delta G is equal to delta H minus T delta S. Straight away we can take irrespective of equation. So for this delta H is given as 145.6 kilojoules per mole. So 145.6 minus kilojoules they are given. Here very important, into 10 to the power of 3. So I'm rubbing this. You have to see the units also. 145.6 into 10 to the power of 3 because into 1000 joules because both should be in joules minus T. What is the value of T? 300 kelvins into 116 joules per Kelvin per mole. So substitute this. So 145.6 into 10 to the power of 3. 145.6 into 10 to the power of 3, that is 145.6 into 1000. So 145.6 into 1000, we can take it as 145.6 into 1000. It is 1,45,600. 1,45,600 minus next 300 into 116. 300 into 116 is equal to 34,800. So this is equal to 34,800. So definitely you'll get positive value, that is 145,600 minus 34,800, which is equal to 1,10,800. So it is 1,10,800 with positive value joules. So it is nothing but what? It is positive value. Since delta G is positive, delta G is equal to positive, the reaction is non-spontaneous. 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 Let us check the answer now. So it is non-spontaneous, as I told you. 110.8 kilojoules. So 110,800 joules. So both are same. So it is non-spontaneous. In this way, you have to check. So whether the reaction is spontaneous or non-spontaneous by taking the values of enthalpy change and entropy change and temperature, easily we can find out delta G value. Delta G is equal to delta H minus T delta S. I hope it is clear. Next question. So it is non-spontaneous. Next question. Using the data given below, calculate the value of equilibrium constant for the reaction. 3 moles of acetylene changes to 1 mole of benzene gas at 298 kelvins. And they have given delta G of formation of acetylene is equal to 2.09 10 to the power 5, and delta F G of benzene is equal to 1.24 10 to the power 5. R value is equal to 8.314. So what is the relation for delta G? So delta G is equal to minus 2.303 RT log Kc. This is the equation for finding delta G. Using the value of delta G values, find the equilibrium, calculate the value of equilibrium constant. First, from the given equation, we have to find delta G of the reaction. So delta G is equal to, delta G degree is equal to sigma of delta G of formation of products minus sigma of delta G of formation of reactants. So let us take, what is the reactants? This is the reactant acetylene and benzene is the product. So only one product. So it is given 1.24 into 10 to the power 5 minus 2.09 into 10 to the power 5 into 3, because we have to multiply with 3 because 3 moles is used. So 3 into 2.09 into 10 to the power 5. So if you calculate this, you will get delta G value. So delta G is equal to, let us take into consideration, now I'm doing calculation part. So it is equal to 1.24 into 10 to the power 5 minus 3 into 2.09, 3 into 2.09 is equal to 6.27 into 10 to the power 5. Taking 10 to the power 5 common, 10 to the power 5 into 1.24, 1.24 minus 6.27 is equal to minus 5.03. So into 10 to the power 5, you have to multiply this. Then you will get the value of delta G. So here I'm not finding delta G value because delta G is equal to minus 2.303 RT log base 10 Kc. So by this you can say log Kc is equal to delta G by 2.303 with both minus 10 RT with both minus 10. So minus minus becomes cancelled. So that is equal to 5.03 10 to the power of 5 divided by 2.303 into R value is given how much? 298 kelvins. Temperature value is 298 kelvins into R value 8.314 into 298 kelvins. So if you do substitution of this, you'll get the answer. That is log Kc. So Kc is equal to anti-log of that. So if you multiply this, you can do it like this again. So you'll get 1.429 10 to the power of 88. 1.429 10 to the power of 88. I hope it is clear. So log Kc is equal to this. So Kc is equal to anti-log of this value. Anti-log of this value, you get as 1.429 10 to the power of 88. I hope it is clear. So please note down this question. So delta G is equal to minus 2.303 log RT log base 10 Kc. This is the formula for finding equilibrium constant. So from this, first we need to find delta G. So delta G is equal to sigma delta G of formation of products minus sigma delta G of formation of reactants. So that is 1.24 in 10 to the power 5 in case of benzene, that is product, and minus 3 into 2.0 in 10 to the power 5, that is 3 by we have to multiply because 3 moles of acetylene gas. 3 moles of acetylene gas. So that's why we get this answer. I hope it is clear. After finding log Kc, we have to find anti-log of this. This is a huge, big numerical. I hope it is clear. So please copy down. Next. So now some more questions we'll discuss based on this delta G. We're adding question number 4. Question number 4 now, because these questions are most important. So theoretical questions as well as numericals. Yes. Now based on combustion, free energy, Gibbs free energy. Question number 4. Combustion of hydrogen. Combustion of hydrogen in a fuel cell at 300 kelvins is represented as 2H2 plus O2. This hydrogen gas is been undergoing combustion. It forms 2 moles of water. That is gas, water vapor. If delta H and delta G, that is enthalpy change and standard free energy change, are minus 241.6 kilojoules per mole and minus 228.40 kilojoules per mole of H2O. Then the value of delta S for the above process is option A 4.4 kilojoules, option B minus 88 joules, option C plus 88 joules, option D minus 4.4 minus 44 joules. Sorry, writing it again, is equal to minus 44 joules. So let us check the answer now. So we know delta G is equal to delta H minus T delta S. By this we can say delta minus T delta S is equal to T delta S is equal to delta G minus delta H minus T delta S. That is minus T value is given how much? It is 300 kelvins. So 300 into delta S is equal to delta G minus delta H. What is delta G? Delta G value is given as minus 228.4. So minus 228.4 minus of minus delta H value is given minus 241.6. So it's equal to 228.4 plus 241.6. So 228.4. So it is nothing but from 241.6 we have to subtract 241.6 minus 228.4, which is equal to 13.2. So this is equal to minus, this is minus and this becomes plus. So it becomes 13.2. So delta implies delta S is equal to 13.2 divided by minus 300. And this is in kilojoules. So multiply with 10 to the power of 3. So 13.2 and 10 to the power of 3 is how much? So it is 13,200. So now 13,200 divided by 300, which is equal to 44 with the minus sign. Minus 44 joules is the answer. So option D. So in this way you have to calculate. Whatever the reaction is given, just forget about the reaction. If the delta G value is not given for the reaction, definitely they will give heat of formation of reactants as well as products for heat of formation, or sorry, they'll give delta G, that is standard heat of formation. Sorry, standard free energy formation of reactants and products will be given. So we can take like this. I hope it is clear. Next question. Question number 5. Question number 5 now. Simple theoretical questions we will do now. Let us see. On NEET level, they'll ask theoretical questions. For an endothermic reaction, for an endothermic reaction, delta S is positive. It is entropy change. Change in entropy is positive. Then the reaction is option 1, feasible. It is spontaneous. Feasibility or spontaneous, both are same as I told you. When feasible when T delta S is greater than delta H. Second option, feasible when delta H is greater than T delta S. Third option, feasible at all temperatures. Feasible at all temperatures. And fourth option, not feasible at all. Not feasible at all. For this question, we have to use Gibbs-Helmholtz equation. So based on Gibbs-Helmholtz equation, we know delta G is equal to delta H minus T delta S. If T delta S is greater than delta H, so this becomes minus of minus, so this becomes plus. So let us say delta H is equal to 1 and T delta H is equal to 2, so minus of minus 2, because T delta S and delta H is positive, they are given. So minus 1 minus 2, it is equal to minus 1. So delta G is negative, it is spontaneous. So answer is first option. Because I'm simply taking delta H is equal to 1, T delta H is equal to 2, and if T delta H is equal to 1 minus 2 becomes minus 1. So it is feasible when T delta H is greater than delta H. Even though if delta H is positive, the above reaction is feasible when T delta S is greater than delta H. I hope it is clear. Next question. Question number 6. Like the simple questions also they'll ask for entrance exams. Next question. For the process H2O liquid, 1 bar pressure and 373 kelvins is changing into H2O gas, same temperature and pressure, that is 1 bar pressure and 373 kelvins. The correct set of thermodynamic parameters is thermodynamic parameters is first option delta G is equal to 0, delta S is positive. Second option delta G is equal to 0, delta S is negative. Third option delta G is equal to 0, delta G is positive. Here we don't have place, but still I have tried to write. Please try to understand. Delta G is positive. Delta S is equal to 0. And fourth option, delta G is equal to negative and delta S is also negative. So delta S is positive. So correct set of parameters. So this is a typical question where for this process is at equilibrium, because you can say at the same temperature and pressure, liquid is changing to gas. So it is nothing but equilibrium. For equilibrium, delta G is equal to 0 and delta S, since liquid is changing to gas, so definitely entropy is increasing. Since liquid is changing to gas, so delta S is positive. Delta S is positive and delta G becomes 0. So answer is first option. I hope you understood. Since liquid is changing to gas means entropy is increasing. So liquid is disorder, but still gas is more disorder. So entropy is increasing. So delta S is positive. And this is at equilibrium, we can say, because same temperature, same pressure, water and water, but only liquid form and gas form. So only phase transition taking place. So delta G should be equal to 0. I hope it is clear. Next question, question number 8. Now question number 7. Question number 7 now. Next question. The value of delta G. The value of delta G for the process H2O solid changes to, that is dry ice, you can say ice, H2O liquid at 1 atmosphere and 260 kelvins. 260 kelvins is option 1 less than 0, option 2 is equal to 0, option 3 greater than 0, and option 4 unpredictable. Unpredictable. So it's very simple, typical question. You can just see here. So let us see now. 1 atmosphere and 260 kelvins. 260 kelvins less than 0 degrees. Less than 0 degrees, we cannot convert solid of water solid into water liquid. Means ice cannot be changed into water. Only ice can be changed into water at 0 degrees. Since ice can be changed into water at 0 degrees C only. 0 degrees C means it should be 273 kelvins. But the temperature here is 260 kelvins and atmospheric pressure is same. If this is different, we cannot say it is unpredictable. But since this is atmospheric pressure is given, atmospheric pressure is given, so we can say this should be What is the value of this? You can guess it now easily. So the answer is third option, that is greater than 0, because it is non-spontaneous. Because ice can change into water only at 273 kelvins, but less than that temperature, it is non-spontaneous. So answer is C. For non-spontaneous, delta G is greater than 0. So like this concept-based questions also you may expect for the entrance exams. Is it clear? I hope it is clear. Next now, continuation. Same questions continuation. Up to 10 questions we'll do, important models. What is the free energy change? What is the free energy change delta G? That is delta G, already we know. When 1 mole of water at 100 degrees C and 1 atmospheric pressure and 1 atmosphere pressure is converted into steam, is converted into steam at 100 degrees C and same pressure, that is 1 atmospheric pressure. So this is possible because we can change the boiling point of water is 100 degrees C. So answer should be 540 calories they have given, minus 9,800 calories, and option C plus 9,800 calories, 9,800 calories, and option D 0 calories. Very, very important question. So we can say for this question, since when 1 mole of water, we can say water is being same above question only. Water changes to water vapor, that is steam. I'll write here instead of water vapor, we'll write steam better, because both are same compounds chemically, but physically they are different. One is in liquid form, another is in gaseous form. We can say it is possible at 100 degrees C, because the boiling point of water is 100 degrees C and 1 atmospheric pressure. So for equilibrium process, we can say this is the equilibrium temperature and the process is called equilibrium process. And for this equilibrium process, already we know for all equilibrium processes, if the reaction is at equilibrium or if the process is at equilibrium, if the process is at equilibrium, delta G should be equal to 0. So answer is 0 calories. Fourth option. I hope it is clear. Like these questions you are expecting for entrance examinations. Now question number 9. Question number 9 now. Please note it down in your classwork again and again. Identify. This is straight JEE means question. You can see. Identify the correct statement. The correct statement regarding spontaneous process. Regarding spontaneous process. Option 1, that is first option A. For a spontaneous process in a solid, for a spontaneous process in an isolated system, in an isolated system, we can say What is an isolated system? Where matter and energy both will not, neither matter nor energy will get transferred to the surroundings. Neither matter nor energy transfer to the surroundings. The change in entropy is positive. The delta S is positive. Option B, endothermic processes. Endothermic means endothermic reactions where heat is absorbed. Endothermic processes are never spontaneous. This is also a wrong statement because it can be spontaneous provided the value of delta S, that is change in entropy. So third option, let us see third option now. Exothermic processes are always spontaneous. Exothermic processes are always spontaneous. Next, option 4. Let us discuss this question detailedly. Next, option 4. Lowering of energy. Lowering of energy in the reaction process. In the reaction process is the only criterion. Is the only criterion for spontaneity. Criterion for spontaneity. So in this we have to identify the correct statement. Identify the correct statement regarding spontaneous process. For a spontaneous process in an isolated system, delta S should be positive. What is the isolated system? Neither heat is given out nor matter is given out to the surroundings. So this is true because delta S should be positive for spontaneous process. And endothermic processes are never spontaneous. That is wrong. And next, exothermic processes are always spontaneous. This is also based on delta G and delta S because it is based on spontaneity is depending on three factors: delta G, delta H, and delta S. So only for one we cannot say. So that's why this is also wrong. And lowering of energy, actually this should be free energy in the reaction process is the only criterion for the spontaneity, that is correct. But lowering of energy is given, so this is also wrong. So answer is first option. This is straight JEE mains question. I hope it is clear. Now we'll discuss the last question for this session. Then in the next session, we'll do other topics. So last question in this session, I'm doing it now. Please note it down. Question number 10. Simple. Which of the following is spontaneous? Is spontaneous. This is previous NEET question. At all temperatures and pressures. At all temperatures. Simply temperatures I'm giving. At all temperatures. Option A, delta G is equal to negative. Delta H negative. And delta S is also negative. Option B, delta G is positive. Delta H positive. And delta S positive. Option C, delta G negative. Delta H negative. And delta S is also negative. Option D, delta G is negative. Delta H positive. And delta S negative. All three positive will keep. So one negative. So in which of the following is the spontaneous at all temperatures? So delta G is negative. Definitely it is a criterion for spontaneous reactions. Delta H negative, delta S negative. So this is based on the table which I have given, if you remember. So If you take delta G is equal to delta H minus T delta S, so automatically delta H is negative and minus T delta S is also negative. So if both are negative, so automatically delta G becomes negative. So it is possible at all temperatures. So answer is first option again. So delta G is negative, delta H is negative, delta H is negative. If all three are the negative, the reaction is spontaneous at all temperatures, not only at low temperature or high temperature, at all temperatures. I hope it is clear. So with this, I'm closing this session. So in the next session, we'll discuss more questions based on thermodynamics. Explanation part of this chapter is finished. Next, we are going to do more competitive questions in the next session and also summary of the chapter. I hope you understood. Thank you all.